Welcome to Venture Step Podcast. We discuss entrepreneurship, industry trends, and the occasional book review. I spoke about robots and NVIDIA, Figure 01, and some other robots. I think I also touched on Boston Dynamics, and then I also touched on Tesla's Optimus robot. And in that episode, I also touched on the infrastructure that NVIDIA was building. And the episode, I think, is called AI butlers and NVIDIA's Superbrain, which I don't know why I called it that. It was a horrible name when I'm looking back, but I spoke about that in March, I think March 19th, 2024, about a year ago, or just over. Or it's over a year, but you know what I mean. Like it's pretty close. And in that episode, I talked about the different programs that NVIDIA was building and how they all piece together into this seamless training experience for the robots, and being able to easily put on some VR headsets and some gloves, control the robot, teach the robot how to do something, take that 3D image, or I guess 3D render, or you could render it because you have the 3D cameras on the robot and sensors. So then you take that 3D rendering and the colors, throw that into Omniverse, and then there you go. From that 1 or 2 hour training experience with the robot in person, now you've trained years on that one item in the virtual world, and then you can transfer that back to your mini robots on your fleet. Quite dense, quite interesting. But then last month, NVIDIA had their NVIDIA AI Day, I'm pretty sure. And during that conference, they spoke about one thing that I didn't get to touch on because there's been so much stuff coming out. Everyone wants to make their announcement. But NVIDIA announced their Grook Isaac N1, and that was their robotics open source model that you can use Omniverse to train new applications for. But it already starts out, it already has like a lot of things that are built in, kind of like if you did ChatGPT, but then you wanted to do it for health insurance or health or whatever it may be, manufacturing. Like it knows manufacturing, but it might need a little bit of help in certain areas. And so NVIDIA built this foundational model for companies to train on it. So instead of me explaining it, I'm going to share my screen and we're going to watch a quick video of the actual explanation of NVIDIA. So let's do this. Open this right here. Share my screen. Audio as well, of course. By the way, if you can't see my screen, you'll be able to hear the audio. But I wanted to call out how cracked my side panel of video suggestions are. Just VC, NVIDIA, robotics, MIT. I mean, just nonstop. We got this lo-fi girl thing going on. So just wanted to call that one out. That I'm doing it for everybody. Just messing around. All right, so let's go to theater mode. Maybe zoom in a bit. Maybe like 175. Maybe too big.
NVIDIA Isaac GR00T is a platform of sim-ready data, simulation frameworks, and synthetic data generation blueprints, and pre-trained models. NVIDIA Isaac GR00T N1 is an open generalist foundation model for humanoid robots. GR00T N1 features a dual system architecture for thinking fast and slow, inspired by principles of human cognitive processing. The slow thinking system lets the robot perceive and reason about its environment and instructions, and plan the right actions to take. The fast thinking system translates the plan into precise and continuous robot actions. While internet-scale training data provides common sense and reasoning. It doesn't teach robots specific actions or control. So we need better data and more of it. Human demonstration data is limited by the number of hours in a day. With GR00T blueprints for synthetic data generation built on NVIDIA Omniverse and Cosmos, we can exponentially multiply a small number of real-world data captures into a massive, diverse training dataset. GR00T N1's generalization lets robots manipulate common objects with ease and execute multi-step sequences collaboratively. Across many environments and even multiple embodiments. And with synthetic data generation and reinforcement learning, humanoid robot developers can post-train GR00T N1 for their specific robot and task. The age of generalist robots is here, driven by developers building on NVIDIA Isaac GR00T.
It's pretty cool, right? Yeah, I thought so myself. I think it's something similar to when Google was first starting. The more people that use the internet, the better, right? The more people that are building robots, the better for NVIDIA, because NVIDIA is the person that's offering the chips for the robots, especially for smaller companies that don't have the infrastructure to build their own chips. And the only companies that have the infrastructure to build their own chips would be companies that are foundries or are companies that can afford the R&D costs and overhead of those kind of expenses. And the companies that can afford to do that are very, very minimal. And the companies that are interested in that kind of thing is pretty much just Google and Meta. And then anyone else building chips, they build chips because that's what they do. So NVIDIA is always going to be building chips. Intel's going to be building chips. AMD's going to be building chips, but they're not competing with NVIDIA. But Google has their TPUs or tensor processing units. And then Meta is working on a chip in-house, but I don't think that chip is going to be, I mean, it's supposed to be for AI. I'm not too familiar with Meta's chip. I know that they're just spending a lot of money to develop. But as I was saying, is that if you're any kind of startup or if you're not Meta or Google or some just massive trillion-dollar market cap company or worth hundreds of billions, then your easiest bet is to use NVIDIA's hardware, their GPUs, their infrastructure to do real-time teleoperating and training, and then use Omniverse and Cosmos. And it didn't explain it in that video, but Omniverse is a physics-based, like real-world engine, and it's used to simulate the world, and it's supposed to be as close to a real-world simulation as it can get. So that's what Omniverse is supposed to be doing. And there's all sorts of crazy things like simulating global warming or different events, or if you drop a rock, like how a meteor hits, like how big are the waves, or whatever it may be. And it also has a practical application for things like training robots, and that's what NVIDIA is using. But I think it took them like 7 years to build the engine. Like it took a long time. And using Omniverse and Cosmos, you're able to train the robot, and it's just overall sick. Like, I don't know. So to emphasize how sick it is, I'm going to share this 1-minute video of NVIDIA and 1X collaboration. And basically in this collaboration, and I didn't know this until earlier today, but I'd watched the demo from 1X about their Neo robot. And the Neo robot was doing household tasks like in a home with another human in the home, which is unusual because a lot of these robot demos, they're in controlled environments, they're in a lab, they're in a warehouse, they're not in somebody's home for the most part. I mean, there's some videos, but like they seem very controlled. I think Tesla has a video of a robot in a house, but it didn't seem like people like lived there. Whereas the I can't say XAI because that's a different company, but 1X, 1X and NVIDIA did a partnership, and their engineers like lived together or worked together for like a week to get this all squared away. And overall, once you have that background, you could see, okay, wow, they did all this in 1 week. It's pretty cool. So I'm going to share my screen again. So share this tab instead. And I'll play this video. Let me go in theater mode.
No way, really?
OneX AI team and NVIDIA Gear are both super determined to bring general-purpose humanoid robots into the world. We think that by swapping notes on how to solve autonomy problems on Neo, we can dramatically accelerate the timeline for bringing Neo into people's homes.
We spent about a week together in a home, like trying to get Neo to basically load the dishwasher and help with household tasks. It was great collaborating with 1X and all of the engineers there, like this cross collaboration, putting the minds together and like working together and solving this. I think that it was a lot of fun.
It's amazing like how fast we can get this done. It's like in 1 week. It's the first time I saw the policy working and it can do like the handover, which we don't expect that happen. At the moment, like, I feel like, hey, we can do it.
Stop sharing. So instead of telling you that this open source foundational model built by NVIDIA is a big deal, including the teleoperating and the Omniverse piece for the training, I wanted to show you with those two videos. Obviously, when 1X AI, that's going to confuse me because 1X and XAI, they sound very close. 1X AI spent a lot of time on the engineering aspect of building the robot and getting the right sensors and getting the product in the right space and having it operational with this just everything that goes on with having a battery operated robot that can move and is textile, has textile sensors, understands objects in a way with your touch and your sensors. Because you could have this foundational model, but if you can't link everything all together, then it's kind of worthless. But for them to be able to do everything they said in a week with just a little bit of collaboration and hard work, I think emphasizes how big of a deal that is, where instead of everyone building their own model, there's this already pre-built model that people can just attach onto, and then they can add or change things out from the model. And that will dramatically reduce the resources required to get started and allows people to focus on the things that they need to, like specified tasks for the robot that it doesn't come out of the box from the foundational model. Whereas before, people were all building their own models and it doesn't make much sense. Everything is closed source. And from NVIDIA's perspective, people using the model, having it being open source, and integrating very well with NVIDIA products, it's a win-win for NVIDIA because if you open source it and then that's the preferred model for your hardware to run these AI chips on, then it just makes everything more seamless. And, you know, the kid at home who's in high school or middle school that dreams about robots, they're going to use the open source model, the model that's easiest to use, all of that stuff. And then eventually when that person grows up, they'll be using that same company probably. So it really helps out. Like I like when I started learning programming, I was in the Google Developers Club. And that's a club that's sponsored by Google, and they give you like hundreds of dollars of Google credits. You build projects, you pitch things, you go out and you try to help charities and in these different aspects. And you do that with using Google products. And you're able to do that because Google makes it pretty much free. They give you a substantial amount of credits, free classes, and if you do well, they'll fly you out to California and you get to present your project. And then you also, I think you get an internship, something like that. Like they set you up for sure. But even if none of that stuff happened, you still get a lot of opportunity to learn with all of their stuff. So just an example of like how this thing can trickle down and over like a 10-year period. But yeah, it's a game changer because it removes the barriers to entry by a lot, and it also allows people to tinker and try things out. Like once you put something in the hands of millions and millions of people are going to build cool stuff. I mean, it may be from someone that doesn't have this established background and wouldn't be able to interact with these things unless they were working at that company and working with their closed source model. And so I'm a big believer in open source simply because it gives everyone an opportunity. But that doesn't mean that an opportunity doesn't mean that there will be results, because a lot of results are by determination and grit. And you can see that's true with a lot of these high end universities or highly esteemed universities like Harvard, Stanford, MIT, and the list goes on. They have open sourced all of their courses, their lectures. They put them all on these websites, and they're all free. They're on YouTube or wherever you watch them. You could also take the exams, all the coursework, and people just don't do it. Like people just won't do it. So, and it's just such a weird thing. Like just because things are open source and things are available doesn't mean people are going to apply themselves. But kind of on a tangent there, but really what I'm trying to say is that it's really cool, and it's cool because it allows builders to build, and things are going to become even more interesting. And it just seems like every month there's something crazy that comes out, or every couple of weeks right now, and it's just hard to keep up with, hard to just understand the velocity of which the world is moving at the moment in terms of technology. There's just so much going on, and it's moving so fast that it's exciting. It's so exciting. There is no doubt that like 5 years from now, you won't even know what that looks like anymore. Like it's just the trajectories of how things are moving are just so much faster than what were anticipated like 3 to 4 years ago or 5 years ago. And then here we are into the present day, and I'm like, I don't even know what 6 months looks like from now, because 6 months from now it could be like there could be like 5 monumental announcements all at one time. So much. It's very exciting. So I'm thrilled with it. And I think that it's going to open up a lot of opportunities for other shops to get into robotics. Like you could be like an engineering shop, but you know, doesn't necessarily have all the infrastructure to build robots. But now that you have this open source model, really all you need to do is integrate all the sensors, and you could have like a crappy robot. Doesn't mean your robot's any good, but you can at least try to build something. I don't know. Anyways, so I wanted to then talk about 2 more robots. We're on a robot talk right now. We're talking about robots today. That's what I want to talk about. So I was really interested. I was writing a paper on, or I wouldn't say paper. I was writing an article on one of my podcast episodes because I want to get all my podcast episodes in an articles format. And from those article formats, I'm going to have them all online on a blog. And that blog will have all of the podcast episodes and an ability to watch them and a link to the website. And I'm doing that simply because who knows how long we have to live. And I would really like to have everything structured if I have to leave early. I don't know. So, and was definitely inspired by Paul Graham's essays and read them throughout college. And now still. And so I also want to start writing like essays, like kind of like a Paul Graham style essay, not to imitate him, but use him for inspiration. So I want to do something cool like that. And I need a website to put all my stuff there. So while I was writing this article, I had remembered about the Figure '01 robot. And I was like, oh, like I wonder how that company's doing. And I also wanted to link the video that I talked about in the podcast onto the article. And behold, they have an announcement with this Helix X or Helix AI. They now have another kind of cool announcement that happened a month ago that I'd missed. So I want to show you that. And it's a real-time reasoning model. I think prior, their reasoning model was a partnership with OpenAI. I don't know the whole background and architecture of the Helix AI model that they're talking about, but in a general sense, it seems pretty cool. And then they came out with a new robot about like 10 months ago that looks very sleek, but it looks strong. Like its arms, I mean, it's got some serious forearms. And they're doing this one demo that I saw online a couple days ago where they're pushing the robot around and the guy's pushing it with like a steel pipe with like padding on the end of it. And the robot kind of like deflects the push a couple times and the steel meets the arm. And man, like it just, those robots are buff. Those are some buff robots. And then so I have that. And then there is also the Boston Dynamics Atlas robot, which I think is kind of freaky. They're talking about how it's like the most efficient robot and it's got all these cool features. It could do somersaults, run, and it does all sorts of like crazy stuff that the other robots can't do because Boston Dynamics has that level of foundation because they've been doing robots for like 20 years. But man, is it freaky. Like they're doing this demo and I'll show it later on in the episode where the robot is picking up this part for manufacturing sequencing. And basically the robot takes the SKU of a part and puts it in the right bin. And so like all your engine covers will go here and maybe your red engine covers on the bottom row or wherever they are. And then instead of like turning around, like I'm on video, but like instead of turning around, it does a full 180 with its head and then just starts walking backwards and then does like a 180 with its torso. And it's freaky. And then in the beginning of the video, they have the robot laying down and they turn it on. Crazy stuff. And the robot, like, I don't know how to describe it. It does like this freaky, like, exorcist thing and like comes up, but like flips its arms around and its legs around like 360 to get up. Freaky stuff. Like it just looks so weird. And the 180 head turn and torso turn is a bit unsettling, I would say. Like I feel more comfortable with the figure robot because the figure robot seems chill. But the 180 turn was just like, oh my goodness. And there's a top comment on that YouTube video is like, imagine you say like, hey, what are you doing to the robot? And the robot does a 180 turn and just says like, what did you say to me? You'll know what I'm talking about if you look up the video or if you're watching right now. But so let's share my screen. So for the first one we'll do is Helix. And yeah, let's do Helix. All right, so let's do this. Helix. A lot of sharing today. I'm feeling very, very thoughtful. It's Mother's Day.
Hey, Figures, can you come here? Okay, I'd like to try something new. Even though this is the very first time that you've ever seen these items, I'd like you to use your new Helix AI and try to reason through where you think they belong in the scene, and then work together to put them away. Does that sound good?
So there's not a lot of narration on this, but basically there's two robots in this home lab that are putting away the groceries, and it takes a lot longer because they're robots, but in a general sense, they're doing their job well, and they're collaborating with each other, and they're handing each other items, and one person is putting stuff in the refrigerator, and the other person is putting away things like in the dry pantry. And they're thinking, they're walking around, and they both know where stuff goes. So if one person has a dry item that's nearby, the other robot's already reaching out their hand to be given that item. So it's pretty neat. So the full video is 2 minutes long. We're not going to watch the whole thing because it's just them fumbling around to get these items in the refrigerator. And so it was around like 9 or so items. And for you to put away 9 items, it wouldn't take you 2 minutes. But if this was something that was not only one task, but the dishes, putting away the groceries, doing the floor, and then you just have somebody turning out work all day, every day, forever, then it does save a lot of time. So I think, it could take them 30 minutes, but then it might take you 15. And then those extra 15 minutes compiled over a whole day of different 15-minute tasks, you'll get hours back. And maybe you don't do cooking every day, or maybe you don't do grocery shopping every day. Like I don't grocery shop that often, but when I do grocery shop, it takes me like an hour to put away everything because I just buy hundreds of dollars worth of food, vacuum seal it up, put it in the freezer, label it, put all my stuff away, and pack it away like a squirrel. And then I'm good to go, and I don't have to do anything for a bit. And then I just have to pick up vegetables. So, but this is the new robot. And if you can't see my screen because you're watching in the car or wherever you are, these arms are buff. Like there's some big arms, and they're just like solid steel arms. And they just, that demo where they were pushing the robot around and it was deflecting it. Oh my goodness. Like people in the comment are like, oh my gosh, those arms are serious. Like if you get hit with those arms on accident, like it's going to be bad. It's going to be real bad. But overall, out of all the robots, I think I appreciate Figures robots the most. on a design perspective, not on application, just design. Like the design of the robots, I think, are beautiful. And there's a video of them walking around, and it looks sick. Like it literally looks so sick. Not so much with the Atlas robot. Like I'm not getting the same like, oh, this is awesome vibes. I'm more like, oh my goodness, this is Black Mirror. Whereas Figure seems more chill. And the design of the robots are just beautiful. Like the aesthetic, the like the glossy gray with the matte blacks and the lights in the right areas. And when it's thinking, the little logo kind of just flutters around in the middle of the screen. And just the way it just looks sleek. Looks great, honestly. Maybe mute this, just fast forward. Like right there, I mean, those look like some cool robots, if you ask me. Loving the design of the robots and how they're approaching the humanoid robot. Yeah, it looks great. Really big fan. So start sharing this tab. So we're transitioning over to the Boston Dynamics robot, and see how this is more like I'm searching on Mars, and it's less chill and relaxing. But this robot video is it's titled it's titled Walk, Run, Crawl, RL Fun, Boston Dynamics, Atlas. Okay, so in that 50-second video, the Atlas robot did a whole bunch of crazy stuff where the robot did a cartwheel, it did a handstand, and it did breakdancing moves. I'm not a breakdancer or an avid dancer, but I don't know what the move's called, but you've seen it all the time in those videos where the person's spinning one leg around and they're alternating their hands, and the leg is going all the way around their body. You know what I'm talking about. That's the move. That's the dirty dance move, baby. Oh my goodness. I'm just making myself a fool. All right. So that was the Atlas. And then I've got one last video here. Mini videos today. Shut this down. So we don't need to watch the whole video. I just wanted to watch and show you the 180 contortions that the robot does. So freaky. Where instead of turning around, it just twists its whole torso and its head, and then like slowly reorientates its feet while it's walking, and then the feet slowly reposition, but the head and the torso are like twisted around, and then it's walking kind of like sideways-ish, and then eventually turns into like a forward motion again. And they said that they did that to become more efficient. Instead of turning around, it's more efficient to just spin around, which I get that part, but man, is it unsettling. For sure, very unsettling. Yeah, that's my main gripe with that. It's just I don't like it. It makes me not so comfortable. So there was a lot of robots. There was a lot of videos about robots. I think the main gist of it is that things are heating up, and all these announcements were made last month. And there's a couple other robots that I'm not going to touch on that are working, and they're Boston Dynamics robots. Figure 01 also, their Figure 01 and then now Figure 02. Figure 02 is doing completed a successful robot test with BMW on their manufacturing plant, putting together bumpers. I think it was the rear bumper. And basically to do that, normally you would have a human that has a big piece and then has the two corner pieces. So the mold is 3 pieces. And once those pieces are kind of put together by a human, then it's sent off to this autonomous manufacturing piece. But the autonomous manufacturing line still needs someone to put the pieces together. So in the testing, Figure 02 completed the assembly of the rear bumper for BMW's autonomous manufacturing line. And so they did that over a couple weeks, and BMW said it was successful, and they're looking forward to reevaluating I think they said like reevaluating the autonomous robot capacity on their assembly line or something like that. So they're looking into it, but they're sensitive about it because they're going to have to either move people or fire them. So people get nervous about that. And especially in a highly unionized industry, I could see how that could cause issues. So I'm sure they're just walking around the subject, but if they're doing the testing for it, they're definitely open to it. That's how I'd feel. Like you're not going to fly robots to Germany, test it in your plant, and then like, oh yeah, I was just thinking about it. I wasn't actually going to do it. Like it was just a thought. Like, come on. You know me. I would never. Okay. All right. Yeah, sure. No worries. But that's Figure 02, and then Boston Dynamics has Spot, which is like the little robot dog that costs 75 grand. And there's quite a few companies that have built additional sensors or capabilities on top of the robot, and they made companies because Boston Dynamics was like, oh, the robot's not ready. Like, there's stuff wrong with it. But now Boston Dynamics is like providing like actual value with the robot, and so basically, what they're thinking that the robot's applications are for are with like monitoring and understanding the sensors or manufacturing of like power plants or industrial sites that are quite big, and then maybe they're building it out and they don't necessarily have the sensors yet, so Spock can walk around and monitor everything and kind of have a verification, or if like a sensor says that there's some anomaly going on, instead of sending a human out there to walk all the way over to it, it would be sent by, or it'd be monitored by Spot. So Spot would get a notification, Spot would turn on from its doghouse type of thing where it's charging, and then Spot would walk over, look at it, and then all of that data is integrated into a product that they built called Orbit. And then Orbit will give you a fleet monitoring system that is verified by Spot, and that data is integrated and uploaded to the cloud, and allows people to manage things from a robot perspective, like as a dashboard, the KPIs. and the data is created by the robot's sensors walking and monitoring the place. And it's pretty cool, the application. I know my father works in construction, and he does like large construction projects. And recently, one of his jobs that he's in charge of overseeing, they're partnering with this AI company that scans and creates or translates the blueprints for the company instead of having the different trades come out and translate the results. So for these large construction companies, they have this CAD software that 3D prints, or it's not printed, but it's a 3D model of the building, all of the wires, where the walls are going, which walls are structural, which ones aren't going to be. And then you could look at it in different phases of the project. But the problem is when you're translating the blueprints over onto the actual like flooring of the building, it could take weeks for each trade to do it. And then one trade is reliant on another trade, and then vice versa. So if one is delayed, then the other person's delayed. And then since that person's delayed, then the two people after it are delayed. And so it causes a mess. And there's this robot company that prints out or understands the CAD model, and then from there prints out all the blueprints for the job site. And the only thing that the user needs to do is move the robot up and down the floors. Like the robot can't climb floors, but it's pretty good. Like, so robots are becoming more and more useful and practical in everyday life. And then I had another robot that I want to talk about, but I'm not going to share a video or go too deep, but it's a robot called the Stretcher. Man, now I am like blanking on the name. What is it called? What is it? Oh, it's called Stretch. I wanted to call it the Stretcher for some reason. It's called Stretch. And Stretch is another robot by Boston Dynamics that is partnered with Gap and some other companies. But basically, Stretch is a robot that is non-stationary and can move around. But once it's starting its job process, it doesn't necessarily move around as much. And the general sense of Stretch is it's a robot that has like kind of that manufacturing arm that you've seen a lot of videos of. And then on that manufacturing arm, instead of a grippy, like where it grabs things, it's got these like large suction cups. And so it just like sucks onto a package, which has got to be pretty strong because suction cups don't work that well on cardboard, but that's besides the point. So it has these suction cups and it sucks onto the box, and then it's got this AI scanning thing that allows the robot to understand where the package needs to be orientated onto the conveyor belt for their scanning software to work. Or wherever their scanning software sensors are positioned, it will position that box to be the correct way so it can integrate into the company system. But basically, instead of somebody unloading and loading different truck containers, Stretch, I wanted to say Stretcher, it's Stretch. Stretch is doing that for the workers. And in the video that I watched, it was saying that workers that would unload the truck, like each truckload or like per day, the average box for Gap was 30 pounds. And the people that would unload the truck, it was a bare minimum requirement to do 3,000 boxes per day. So that's 90,000 pounds of moving. Like that over 5 days is almost 500,000 pounds. And then let's do 90,000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000. 90, 90, 000 let's do like 40, because maybe you have weeks off. That's 18 million pounds just from your job. It's a lot. Basically, what the guy was saying is that it doesn't allow people to work that job too long because of how brutal it is on your back and your body. And eventually your body just kind of just gives out. And stretch allows people to still work the job, but not have to work with that level of physical strain, and then also work weekends with less people and overall make everyone more productive and happier. And then instead of the workers, and you're upskilling the workers too, because instead of them moving boxes, they're controlling and robot certified to control robots, and then move the robots into the truckload, operate it, get it to turn on, and then it runs on itself. But you still have to have someone who understands the robot, and then eventually probably moving into robotics repairs or something like that. Like you could learn that. It just provides just different information that you can obtain or make use of instead of just moving boxes. So that was what I wanted to talk about today. I was on a robotics just marathon today with everything I shared with you and the stuff that I watched throughout the week. I was like, I got to talk about robots this week. I've got to do that. Eventually, I'm going to be more centered around probably finance here shortly. That's what I'm probably going to get into in the next couple episodes. I'm just going to be deep down in finance, but more to come on that. But we're closing out here, and I appreciate everyone listening. And wherever you are in this world, have a good day. Either it be morning, night, or the afternoon. Thank you for tuning in, and I'll talk to you next week. Goodbye.